let the other join and wait for the minutes.
Yeah,
Then we will
sure.
start
Yeah, sure.
today's lecture. टीव्ही काय टीव्ही बंद करा. हां हॅलो. हा स्टुडंट्स आवाज येतोय का?
Yes, sir.
हो सर.
साक्षी आवाज येतोय का? शिंदे.
हो सर येतोय.
ओके. हां. नाऊ मी माझा व्हिडिओ बसवता बंद केला ड्यू टू द नेटवर्क बँडविड्थ अँड ऑल. सो ॲज आय सेड अर्लियर so what I have taken photos of that. I will explain from that instead of PPT. Most important thing is that how you are understand the topic. Okay, so no doubt that we shared to you. Now basically, which are the different methods to turn on the SCR or any kind of the thyristor family device? Okay, so basically, uh, there are the so many methods, so many ways to turn on the SCR. Okay, very common method which is widely used, that is a forward voltage triggering. Okay, so what is the best suitable method and the easy method? If you are taking the SCR, take that SCR and apply the forward voltage across the SCR. Okay, so now what will happen? As you know, when the SCR is a forward bias, when SCR is applied the forward voltage, junction J1 and J3 are forward bias, whereas the junction J2 becomes reverse bias. Okay, so when the voltage across the SCR becomes equal to the breakdown voltage or breakover voltage, at that time SCR goes into the on state, means the if there is a enough voltage across the anode and cathode which will break down the junction J2, okay, which will break down the junction J2, at that point of time the conduction takes place, and when conduction takes place I can say my SCR goes to the on state. Is it clear? So this is a very simplest method, okay, uh, uh, for triggering the SCR or any other thyristor family device. Okay. Next important method. Minal is there. Hello.
Yes, sir.
तुला स्क्रीन दिसते का बाळा?
हो सर दिसतीये.
हां. काही प्रॉब्लेम नाही ना? इफ आय एम शोइंग लाईक दिस PDF नो?
नो
Hello.
सर नो.
हां. Now thermal triggering. Now, as you know, uh, when applied voltage is near to the breakdown voltage, thyristor can be turned on by increasing the junction temperature. Now, sometimes you know that with the temperature, the number of carriers are increased. Okay, when increased, increased, right? When number of carriers are increased, at that time, even though even suppose the data that there is requirement of breakage or break voltage of 150 volt, right? So what temperature will happen? Even temperature voltage is 125 volt. Actually, requirement 150 volt to break down takes. Okay, so there is 125. What will happen? With the 125 volt also, if the temperature is increased, right? My ACR so thermal triggering is another method. In that case, if you are using the thermal triggering, the requirement of the forward voltage to be applied across the anode and cathode get reduced. Hello, hello, students.
येस सर.
Well,
सर
समजलं
तुमचा आवाज फार ब्रेक होतोय.
विद्यार्थी कोण- काय करू मी okay. So maybe week I will be no. Okay. So what is in the thermal triggering? So again, the requirement of the forward voltage to be applied across the anode and the cathode of the HCR is reduced. That is called as a thermal triggering. That's you can observe this effect, right, during practical also. In very beginning, you can see the value Hello, hello. The connection was
हाँ सर.
okay. So so far, we have seen the three methods of triggering. One is a thermal triggering, radiation triggering, and the forward voltage triggering. Okay. So here there is another method of the triggering which is called the dv by dt triggering. So basically, what is meant by the dv by dt? Okay, dv by dt means sudden increase in the voltage, right, for the time being. Understand? That is called as a dv by dt, isn't it? So dv by dt is nothing but it is the voltage applied, but there is a sudden increase in the voltage applied. Understand? That is called as the आवाज येतो का मिनल स्टुडंट्स
हो सर
hello
येतोय.
now basically what is meant by the dv by dt sudden increase in the current, right? That is called the di by dt or dt is the increase in current. So dv by dt is another method of the triggering. So basically what happens here, as you know, junctions J1 and J3 are the forward bias and junction J2 are the reverse bias. Now basically junction J2 can be think of as a capacitor. Understand? Junction J2 can be think of as a capacitor with the charges across the junction. Capacitor में क्या होता है? What is happening to capacitor? In capacitor, you can find there is a charges are collected at one plate, positive charges collected on one plate, and negative charges collected on the another plate. So basically, you can treat the junction J2 as the capacitor in which charges are collected at one side, positive charge is collected one side of the junction J2, and negative charge is collected at another side of the junction. So IC is equal to dq by dt, right? So then it is equal to d by dt of, because you know that q is equal to cv. Here we use the term cjv because c is the junction capacitance, cj is the junction capacitance. Okay, so if you apply the rule of the derivative, product rule of the derivative, it will be Cj into dv by dt plus V into d by dt of Cj, where Cj is the junction capacitance. Now, you know, here product rule d by dt of uv or d by dx of uv, we have studied very well, right? So, in this case, v into du by dx plus u into du by dx, that rule we applied here. But here, the second derivative can be omitted. Understand? Second derivative can be omitted because as such, the junction capacitance is not changing with time. It is a constant. As junction capacitance is constant, that can be omitted. So only left term in this expression is IC equal to Cj into dV by dt. Understand? It is IC is equal to Cj into dV by dt. Okay. So ultimately, my current, right, charging current means it is the current through the junction J2 is given by Cj into dV by dt. Understand? That is the mechanism, or this is the principle, right? With the help of which we can study the uh, dV by dt triggering method. Similar to that, another type of the method, another method to trigger the SCR, it is di by dt. I didn't mention here di by dt triggering method because there is no such difference between the dv by dt triggering and di by dt triggering. Basically, what happens in di by dt triggering also? There is a current. Hello, there is a di by dt triggering. But what is the disadvantage of di by triggering is that, The diabetic triggering is that it generates the hotspots. Okay, so when current is increased suddenly, then the more number of carriers will be entering into the SCR. When more number of carriers are entering into the SCR, and if space is less, it will generate the hotspots, and the generation of the hotspots will uh, damage your SCR. Understand? That is the uh, disadvantage of diabetic triggering. Okay, so now do you understand what I studied till now? Four type of the triggering methods we have studied. One is the voltage triggering, paravoltage triggering, thermal, radiation, and the another is dv by dt triggering. Dv by dt triggering I explained you, but I didn't mention in the presentation or the notes dv by dt triggering, because there is no big difference between the dv by dt triggering and dv by dt triggering. Next important method of the triggering, that is called as a gate triggering, which is used in 99% of applications of the power electronics. Okay, so this is a very widely used method, very common method of the gate triggering, because because the gate triggering method is not simple to design, I would say, but that will reduce the requirement of the forward voltage to be applied across anode and cathode. Understand what I'm saying? It reduces the forward voltage requirement. Now, generally, if you see, uh, if you see, if there is a requirement of the 150 volt, that is a breakover voltage given in the datasheet of the SCR, with the help of gate triggering method, we can reduce the requirement to the 20-30 volt also. Understand? So that is a basic application of the gate triggering method. It reduces the requirement of the forward voltage applied. Understand? Because otherwise what could happen that it is very difficult to provide that much higher voltage. In practical also we are using the gate triggering method. Otherwise we would require the forward voltage 200 volt DC. Okay, that's why we are taking the help of gate triggering method while performance during the performance of practical. Okay, now in gate triggering method, by applying a positive signal at the gate terminal of the device, it can be triggered much before the specified breakover voltage. That is very important advantage of the gate triggering. As I said earlier, right? With the help of the gate triggering, right, much before the specified breakover voltage, my SCR can be turned on, right? So requirement of the power voltage is reduced by a large margin. That is the important biggest advantage of the gate triggering method. Do you understand? Hello? Hello students?
Yes, sir.
Okay. Means if you apply the positive voltage between the gate and cathode of the SCR, if you apply the positive voltage between the gate and cathode of the SCR, right, we can turn on the SCR without the much voltage, without the much voltage to be applied between gate and the cathode. I mean to say that for the small value of the current, forward current, right, I can use the gate triggering method. Understand? No doubt, the current flowing through the SCR is proportional to the forward voltage. Understand? But it is possible only with the help of gate triggering. I'm not saying that it is not proportional to the gate current, right? Okay, next. In gate triggering method, there is the another subtypes of the gate triggering depending on the type of the voltage you are applying. Depending on the type of the voltage you are applying between the gate and the cathode. One is DC gate triggering method, in which DC voltage of the proper magnitude and the polarity is applied between the gate and the cathode of the device. Here I am saying that proper polarity, because we know that SR can be turned on by applying the positive voltage. Understand? SCR can be turned on by applying the positive gate voltage. Even though if you apply the negative gate voltage, your SCR cannot be turned on, because the requirement of the gate voltage applied between the gate and the cathode of the SCR is positive magnitude, right? Positive polarity. Okay, so that's why it is said that proper magnitude and polarity. Polarity positive negative चाहिए. In addition to that, proper magnitude means आपको इतना voltage apply करना है so that minimum requirement of the gate current we have studied in the gate characteristics of SCR, requirement of IG mean should meet. Are you agree with this? What I am saying that आपको इतना voltage apply करना है so that current flowing between the gate and the cathode should be more than or equal to IG mean. Understand? If current flowing is not equal to more than that IG mean, because it is a current control device. Understand? आप सीरीज में एक रेजिस्टर बड़ा लगा देंगे तो आपको ज्यादा वोल्टेज अप्लाई करना पड़ेगा. Understand? That resistor will deciding the amount of current flowing. So my SCR is a current control device. Though I am applying the voltage to provide the current, my SCR is current device. Understand? So here uh, I have to apply the voltage such that current will be equal to or more than the IG mean. Okay, and when at what voltage that IG mean will be achieved, that is depending on the resistor you are applying. Resistor you are providing for the protection purpose. Understand? So that is about the gate DC gate triggering. Now in AC gate triggering, basically in AC gate triggering method, so not necessarily you know that AC voltage contains positive half cycle as well as the negative half cycle. Okay, it contains positive half cycle and the negative half cycle. Suppose if we want to turn on the SCR in positive half cycle only, not in negative. Understand? Right? So it's okay. You can apply the AC voltage, the same AC voltage which is applied between the anode and cathode can be used to turn on the SCR. Okay, AC source is most commonly used for the gate signal in all applications of thyristor control. This provides the isolation, right? That is the advantage of the AC gate triggering. Understand? Another one is pulse gate triggering. What happens in pulse gate triggering? In this method, gate drive consists of the single pulse appearing periodically or a sequence of high frequency pulses. So in this case, you are applying the only one pulse for sufficient duration. Again, the duration of the pulse is applied should be more than or equal to T on time of SCR. Are you agree with this? I said the duration of the pulse is applied, right, should be, or time period of the pulse applied should be more than or equal to T on time of SCR. Understand? Should be more than T on time of the SCR. So whenever, suppose if you want the periodical turning on of the SCR, accordingly you adjust the time duration of the pulse, means the frequency of the pulses. T on time is of the pulse should be more than or equal to T on time of the SCR, no doubt. But at what interval again next pulse will appear, that depending on your applications. Okay, so here pulse transformer can be used for the isolation. Any doubt here till this? Hello students, this all about the triggering methods. Hello.
Yes, sir.
हाँ हेलो, सो गए क्या सब लोग?
No, sir.
अक्षय चौहान.
No, sir.
हाँ. So do you understand
Yes, sir. Yes, sir.
various techniques or various methods of triggering the SCR? Akshay, Vinay
Yes, sir.
Sharma,
Yes.
right? Now here afterwards we will study the specific arrangement in the gate triggering method, right? In gate triggering method we will study the specific methods that I will explain with the help of the circuit and the waveforms. Okay, so do you understand various methods? Hello. Okay, draw this circuit, resistance firing circuit. Draw it. Hello. Sakshi Shinde,
Yes, sir.
Akshay Chauhan, Vinay Sharma. Draw this circuit.
करतोय सर करतोय draw.
हाँ, लॉग इन करके उधर सो मत जाओ आप लोग, हाँ? सुनो, लेक्चर सुनो, कीप नोटबुक विथ यू, नहीं तो क्या एक बार लॉग इन कर दिया चलो सोने चले गए, ऐसा मत करो। अभी क्लास में आप सोते थे तो अभी तो अच्छा चांस है सोने का, फिजिकल क्लास में आप सो जाते थे, अभी तो क्या है। ओके, हाँ हेलो, इज ओवर, हाँ ड्राइंग इज ओवर और नॉट?
Yes.
Okay, now see, this is the which type of triggering? Is it a gate triggering? Will anybody answer by looking at the diagram or the circuit diagram or the connection? Can you answer the question what I'm asking? Right? Is it a okay? So is it a gate triggering method? Yes. Akshay Chauhan, सांग रे बाबा. Hello. Vinay Sharma is there. वनिता आएगा वनिता. Hello.
Sir, gate triggering.
Vanita is there in the class? इधर लॉगिन में तो दिख रही है. Okay. सुजीत,
Yes, sir.
सुजीत,
Yes, sir.
ओके, हाँ, इज इट अ गेट ट्रिगरिंग और नॉट?
Yes, sir. It is gate triggering.
या हेमाली इज देयर, हेमाली गिरने.
हेलो सर।
हाँ बोलो.
हाँ सर, ये स्क्रीन मेरे को सर ब्लैक दिख रहा है तो मैं रीजॉइन कर रहा हूँ।
चलेगा. हेमाली है क्या?
Yes,
हेमाली
sir.
प्लीज आंसर. हाँ, इज इट अ गेट ट्रिगरिंग मेथड? यस और
Uh,
नो?
yeah.
हाँ, इज इट अ एसी गेट ट्रिगरिंग मेथड? इज इट अ एसी गेट ट्रिगरिंग मेथड? यस और नो, प्लीज आंसर. व्हाट डू यू फील? हेमाली,
Sir.
is it a AC gate triggering method? Do you understand my question? What
Yes,
I'm
sir.
asking to you? Okay. Why? Why it is a AC gate triggering method? इसके पहले हमने सीखा है टाइप्स. That's why I'm asking you. Is it a AC gate triggering method? EPS. How come you can say it is a AC gate triggering method? Minal, you answer this question. Minal Pawar. Minal. Hello. Minal. हॅलो मिनल. मिनल आहे का लेक्चर मध्ये? हा आहे. हा मिनल, आन्सर दिस क्वेश्चन. कुठे गेली मिनल? Okay, so forget this. Now it is a AC gate triggering method because AC voltage is used to trigger the gate of the SCR. Is it clear? Okay, that's why it is a AC gate triggering method. Here you can see same source is applied between the anode and the cathode of the SCR as well. Same source is applied between the gate and cathode of the SCR. Okay, so this is the AC gate triggering method. So listen very carefully. Draw this waveform. Applied voltage and the load voltage. Hello, and the voltage across SCR. VAK means voltage across the SCR. EL is the load voltage. ES is the applied voltage. Can you see the waveform on the screen? Hello.
Yes, sir.
Draw this. Draw this waveform. Axis. X-axis is the time axis. Clear? X-axis is the time axis. Okay. Here, my AC input is applied across the anode and cathode of the SCR. What happens to this circuit? Let's discuss. If drawing is over, then we will come to this explanation, and you go through the waveforms drawn in the notebook. Hello? Hello? Students, have you drawn the waveforms?
Yes,
Yes,
sir.
sir.
Yes, sir.
Ah,
Yes, sir. Yes.
okay. Now what I'm explaining, you can look to the diagram, which waveform which you have drawn in the circuit, in the notebook. What is the property of input signal AC? That applied signal ES or the AC signal goes positive, the SCR becomes forward bias. Are you agree with this? Because if I start at t equal to 0, my applied signal is increasing. Is ES goes positive, my SCR becomes forward biased. But it will not conduct until its gate current exceeds the IG min. बराबर है? The same signal is used to trigger my SCR, right? You can see the same signal is applied between the gate and the cathode of the SCR. Understand? So here, when IG reaches a value equal to IG min, अभी क्या होगा? Suppose my applied voltage is increasing at t progresses. At some instant of time, right? ES is sufficiently high such that my IG will reaches a value equal to required IG min, right? And in that case, when my SCR is turned on, my circuit gets completed and load voltage will be equal to ES. You see here, this my, when it is turned on, while applying the KVL, right? At this point of time, my ES is equal to EL when SCR is turned on. So at this point of time, let us say this is a 30 degree. Let us say it is the 30 degree. What happens? Till 30 degree, SCR is not turned on. So there will be no load voltage. Understand? Assume that this is a 30 degree. Till 30 degree, what is happening? Till 30 degree, here, suppose this is a 30 degree point. Okay. So at this 30 degree point, IG mean is reached, right? Depending on the resistance, of course, when it will be reached, assume that setting is such that at 30 degree only my required IG mean is reached, my SCR will be turned on, right? When SCR is turned on, circuit gets completed here, and at this point of time, EL load voltage will be equal to ES. मतलब this load voltage will be equal to ES. At this point and at this point, ES and EL will be same. Just assuming that there is no drop across the conducting SCR. Okay. So when SCR is off, please be very clear that when SCR is off, when SCR is off, load voltage will be zero. But there is some voltage you can see VAK which is equal to ES. So what I am saying, when SCR is turned off, when SCR is turned off, load voltage is zero, but voltage across the SCR is equal to applied voltage. Are you agree with this? Hello students. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Again
Yes,
I am
sir.
yeah. Again I am repeating. When SCR is off, load voltage will be zero, but as soon as it's turned on, EL equal to ES. Okay. Now आपको मालूम है when SCR goes on, is a closed switch, it will be short circuited, and across short circuit voltage will be zero. So 30 degree onwards to 180 degree. 30 degree onwards to 180 degree, what is happening? EL will be ES. At this time, what happens? Because forward current flowing through the SCR is reducing, no? After 90 degree, it is reducing. You can see at the point of 180 degree, at the point of 180 degree, current flowing through the SCR becomes less than or equal to 180 degree, less than or equal to holding current value. When current flowing through the SCR becomes less than or equal to holding current value, understand? Then SCR turned off, and as soon as SCR turned off, you can see voltage across SCR will be nothing but the applied voltage, whereas voltage across load is zero. So this is the point of 360 plus 30 degree, like this, or 360 plus alpha. This point is 360. Is it clear? This point is 360. Okay. So as again it's turned on at 360 plus alpha. Alpha is triggering angle. Are you agree with this? Hello students. Perfect.
Yes,
Okay.
sir.
Yeah. Any doubt in this waveform anybody has?
No, sir.
Because again I'm repeating, when SCR is reverse bias, SCR cannot conduct, no, between 180 to 360 degree. Now SCR is completely reverse bias. Negative voltage is applied here. Now SCR cannot be turned on, right? When SCR cannot be turned on, voltage across load will be zero. Circuit cannot be completed. My SCR will be open circuited, and that's why voltage across the SCR will be the negative input voltage. मतलब whatever the applied voltage will be there, that can be seen across the SCR. So again I am repeating, when SCR is turned on, when SCR is on, voltage across load will be applied voltage, whereas voltage across SCR is the zero voltage ideally. When SCR is off, load voltage will be zero, but applied voltage will be equal to applied voltage will be nothing but the voltage across SCR. That I am trying to say. Okay, seeing what I explained here. Understand? So here, what is the use of the diode? Here the diode is used to prevent the gate cathode reverse bias from exceeding the peak reverse voltage, right? Because you know that in negative half cycle my SCR is not conducting, right? As you are using the same source, the negative gate voltage will be apparent between the gate and the cathode, but that negative gate cathode voltage should not be more than the its capability to sustain, and that's why we are connecting one diode, right? Here is the one diode you can see in the circuit. This is the diode. What is the use of this diode? In negative half cycle there will be no voltage between the gate and the cathode. It is acting as, when it is negative, this is negative, this is positive. When it is negative and this is positive, what will happen here? Okay, when it is positive, in this case, this is a open circuited, no? Diode D will be open circuited. When diode D will be open circuited, right? There is no appearance of applied negative voltage between gate and the cathode. Otherwise, what could happen? It can happen that, it may happen that the negative gate voltage may appear across the gate and the cathode. To prevent this, we are connecting this diode over here. Coming to the point, by the now armin यहाँ पे connect किया है. What is the use of this armin? Armin is connected to take minimum time. Even though RV equal to 0, there will be some value of armin. It means that at t equal to 0 or very close to 0, your current requirement doesn't meet. Otherwise, it will damage the my SCR. Okay, here. So this is the limiting resistor Rmin is placed between anode and the gate so that peak gate current IGM is not exceeded. So again I am telling you, the current should not be more than IGM, sustaining value of the gate current, right? We should, even though RV equal to 0, right? Current should not be more than or equal to IGM. Otherwise, what will happen that? What will happen? The gate current will be very high. We want the gate current, no doubt. We want the gate current. It doesn't mean that that current will be so large. Understand? We don't think that current should be so large. When current is so large, again it will damage the gate cathode circuitry of the SCR. Similarly, another resistor which is used here, that is the RB. Understand? So RB is given by the formula which is called as a stabilizing resistor, right? RV plus Rmin into Vg max dividing by E max minus Vg max. That is the deciding value of RB mean. RB is called as a stabilizing resistor. Okay. Here, the thyristor will trigger when ES becomes equal to Ig mean. As I said, it depends on the value of RV and the Rmin. Rmin तो हमने दिया है. It depends on the value of RV. तो आप RV ज़्यादा रखेंगे, right? आपका अल्फा बढ़ेगा. Are you agree with this? Hello students.
Yes, sir.
हाँ, अगर मैं RV
Yes,
टॉप
sir.
पोटेंशियोमीटर है, अगर वो पोटेंशियोमीटर की वैल्यू अगर मैं ज़्यादा रखूंगा तो क्या होगा? This requirement will be increased, no? बराबर ये ज़्यादा रहेगा तो yes, to achieve that much voltage, that will be more. मतलब जितना RV ज़्यादा उतना डिले ज़्यादा. Are you agree? Means लेट होगा my SCR trigger, right? SCR will be triggered late when RV is more. Understand? Are you agree with this? Again, I am saying important statement is that load voltage is inversely proportional to delay angle. Are you agree with this statement? Hello students.
Yes, sir.
Yes, sir.
I am saying one statement. Let me know, are you agree or not? I am saying my load voltage is inversely proportional to delay angle more. If you look at the waveform, you can see when EL is more, load voltage will be more. So average value of load voltage will be less. Of course, load voltage is DC. Load voltage is DC, right? So that load voltage will be less. So load voltage is inversely proportional to the delay angle. Delay angle more, लेट ट्रिगर होगा मेरा SCR. When it is triggered late, ultimately load voltage will be more. So you can see my load voltage and the voltage across SCR are complementary to each other. Are you agree with this? Hello students. I said
Yes, sir.
Yes, sir.
I said load voltage and voltage across SCR are complementary to each other. Are you agree? Okay.
Yes, sir.
देखो, when load voltage is zero, then VAK is there. When VAK is zero, load voltage is there. That's why it is called as the complementary to each other. Next important thing is that here the trigger angle alpha is varied only up to 90 degree. This is a very important statement. देखो, when peak is achieved of input signal, hello students, when peak of input signal is achieved at 90 degree, बराबर है कि नहीं बेटा? हेलो.
हाँ
Yes,
सर.
sir.
Yes,
हाँ,
sir.
अगर मैं आरवी अगर बहुत ज्यादा रखूंगा, पोटेंशियोमीटर बहुत ज्यादा वैल्यू रखा मैं, व्हाट विल हैपन? माय sufficient gate current requirement is not matched, even though my input signal is reached peak at 90 degree. Are you agree with this? If I am keeping my RV is large enough in such a way that requirement of IJ mean is not met, even though my applied voltage is reached its peak. No, peak is reached at 90 degree. अगर 90 डिग्री तक मेरा एसीआर ऑन नहीं होगा तो बाद में भी नहीं होगा ना, वेरी ऑब्वियस है. अंडरस्टैंड? अगर 90 डिग्री तक ऑन नहीं हो रहा है तो बाद में भी नहीं होगा, ठीक है? बिकॉज बाद में तो इनपुट सिग्नल कम हो रहा है मेरा आफ्टर 90 डिग्री, isn't it? After 90 degree my ES or the applied voltage start to reduce, isn't it? After 90 degree my applied voltage starts to reduce. If it is not achieved till 90 degree, it cannot be achieved after that also. My ECR never triggers, right? If I keep RV is large enough. So ultimately what I'm trying to say, is that the maximum delay which can be achieved with this is up to 90 degree. You can set the RV such that my gate current will be achieved, required gate current will be achieved at peak of the input signal, and that peak of the input signal is reached at 90 degree. Therefore, I am saying that the trigger angle alpha can be varied up to 90 degree between 0 to 90 degree. Again, I am saying that exact 0 degree possible nahi hai, because we are connecting one limiting resistor Rmin in the circuit. We are connecting one limiting resistor Rmin in the circuit. There will be some drop across the Rmin. Understand? There will be some drop across the Rmin even though RV equal to 0. Even though RV equal to 0. That's why I am saying that the delay angle alpha achieved maximum is 90 degree. So are you agree with this? Do you understand what I explained today? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now this
Yes,
another
sir.
circuit is left. I don't think it can be covered in the 10 minutes. That is a resistance capacitance firing circuit. And in resistance capacitance firing circuit, the limitation of alpha, which is only 90 degree, can be overcome in the resistance capacitance firing circuit, which is popularly known as RC circuit. This is popularly known as RC firing circuit. No doubt, it is also the AC gate triggering. It is also the AC triggering. Understand? AC gate triggering, but it is you are using the capacitor, and capacitor is used, you can vary the alpha or the delay angle till 90 degree. Okay, that I will be covering in the next lecture. I was planning to cover